Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. In today's lecture we will discuss surface areas and volumes for class 10th, right? In your class 9th you have studied about various solid shapes like cuboid, cube, and then is right circular cylinder, right circular cone and sphere, etc., right? In this chapter we will make use of that knowledge and find the areas and volumes of combinations of these solids. Okay, from class 9th, let us say you know about right circular cylinder, right? This is the right circular cylinder. If I mount a hemispherical solid on it, now it will become a combination of two solids, right? If I put one hemisphere here, it will become another solid. Now if you ask me the area, outer area of this solid shape, it will be a combination of the curved surface area of this cylinder, curved surface area of this cylinder, curved surface area of this hemisphere and this hemisphere, right? So these kind of questions will come in this chapter. First of all, let us revise what we studied in class 9th. We studied about cuboid. So what were the formula of cuboid? We will revise it here. Okay, let us say this is the cuboid. Okay, this is length L, this is breadth B, and this is height H. Okay, so what was the formula for total surface area? You know how many surfaces are there in this cuboid? There are 6 surfaces, right? 1, 2, 3, 4 and 1 in front, 1 in back, 5 and 6, right? 6 surfaces are there. So top and bottom surface will have area. These are rectangles, right? On the top you have a rectangle with area L into B, length into breadth, right? And this surface will have area of B into H, right? And this surface, this one, will have surface area of H into L. So L into B, top and bottom. If I talk about these sides, B into H, and these sides H into L. So total surface area is 2 into LB plus BH plus HL. And I am talking about a solid cuboid here, right? The top is solid, bottom is solid, nothing is open. Okay, so this is the total surface area. And what was the volume of a cuboid with length L, breadth B and height H? It was L into B into H. Okay, this was the volume. And if you talk about this length of this diagonal, if I join this point and this point here, what was this length? This length of this diagonal is equal to L square plus B square plus H square, square root, length of, let us say, diagonal. And I am not talking about the diagonals on the surface. Okay, I am talking about the diagonal of the cuboid, which joins, if you look at the room you are sitting in, you need to join one corner of the room to the right opposite corner of the room, right? Then it will be the biggest diagonal or biggest length that we can place inside the room. It is equal to L square plus B square plus H square, square root. Okay, and you can confirm this by joining this diagonal also. If you join this diagonal, what is this diagonal? This is L square plus B square, square root. Let us say, let me make this cuboid once again. Okay, now I am talking about this length here, right? Now if I join this diagonal here, and this is L, this is B, this is H. So what will be this diagonal? This will be L square plus B square square root, because these angles are 90 degrees, right? So by applying Pythagoras theorem you can find this. Now this surface and this length and this line also has 90 degree angle between them. Okay, these are two surfaces, perpendicular surfaces. So every line on this surface will be perpendicular to this, right? So these are also perpendicular. So this line will be L square plus B square plus H square square root, right? Square of this plus square of this, add these and take square root. So this will be L square plus B square plus H square. So this is what we studied about cuboid. The next shape was cube. Cube also has 6 surfaces. And what is the difference between cuboid and a cube? In cube, all the sides are equal, right? All the edges are equal in length. So if this is L, so this will be L, this will also be L. Okay. How many surfaces are there? 6 surfaces. Every surface, let us say this surface, this has an area of L square. So every surface will have an area of L square. So total surface area is equal to 6L square. If I need to talk about its volume, then what was the volume in case of cuboid? It was L into B into H. In this case, L into L into L. So L cubed is the volume, right? Also, this was about cube. Okay. Now if you need to talk about the biggest diagonal here or the biggest length that we can place inside a cube, you can calculate it like that again. This will be equal to L square plus L square plus L square square root, right? Because L is equal to B is equal to H in this case. So the biggest length inside cube, right? Biggest length that you can place inside the cube is equal to, this is root 3L, right? Because this is 3L square, when you take the square root it will be root 3L. So this was about cube. Let's talk about cylinder now. So this is what a right circular cylinder looks like, right? This is the axis, this is the radius, let us denote it by R. Okay, this line is the axis, okay, and this angle is 90 degrees. So that's why we call it a right circular cylinder. If this angle is not 90 degree, it will not be a right circular cylinder, and it is not in our scope to study. So we are studying about the right circular cylinders only. So if we open this cylinder, this will open like this, okay, and if this radius is R, what will be the circumference? It will be 2 pi R, and when you open it, it will act as the length of this rectangle, right? Let us say this height is H. So what will be the breadth of this rectangle? It will be H. I have just opened this figure like this, okay, I have spread this figure. So what will be the surface area of this cylinder? So surface area, and when I say surface area, I am talking about this curved surface area here, because this is hollow, right? This is open from top and bottom. So this surface area, I am talking about curved surface area. So it will be equal to length into breadth, 2 pi R H. Okay. If this is also solid, right, then the total surface area will be this 2 pi R H plus these two surfaces. These two surfaces are pi r square each. So 2 pi r square you have to add, right? This is all we have studied in class 9th. So then you can take common as 2 pi r, right, from here H will remain inside, from here R will be inside. So this is the formula for total surface area of a cylinder, where top and bottom are there. Okay. So what was the volume of cylinder? Volume of cylinder is nothing but surface area of the bottom, which is pi r square, into height h. So it is equal to pi r square h. Okay. So this is the volume of cylinder. And if I need to briefly tell you about cone also, this is the shape of cone. Okay. Let us say this is radius r, this is height h. So what will be this length? This length will be r square plus h square square root, because we are talking about right circular cone. Okay. So this angle is 90 degrees. So this length, which is the slant height, right? We also know it as slant height. This is denoted by L also. So L is slant height, and it is equal to r square plus h square square root. Okay. So what were the formulas? If you talk about this curved surface area, this is equal to curved surface area is equal to pi r L, right? And what is this area in the bottom? It is a circular portion, right? If you look at the cone, the bottom is circular. So if you need to find total surface area, you need to add pi r square in it. Okay. So this is the total surface area of a cone, right? And you need to talk about volume. Volume you can memorize that it is 1/3 of the cylinder. So 1/3 of the pi r square h, right? Because if you fill 3 cones of radius r and height h and put it in the cylinder of radius r and height h, it will take 3 such cones to fill the cylinder, okay, of the same radius and same height. So the volume of a cone is 1/3 of the volume of a cylinder with same radius and height. Okay. Then we studied about sphere also. Let us say this is a solid sphere. Okay. What was the surface area? Surface area was 4 pi r square, right? And volume was 4/3 pi r cubed, right? And if you take half of this solid sphere, if you cut it into half, then there will be a circular shape on the bottom of this, and this is known as hemisphere. What will be the volume? It will be exactly the half of this volume, right? So 2/3 pi r cubed. But if you need to talk about surface area now, surface area will not be half of this surface area. Why? Because we have got another surface here. This is the new surface that has been generated. So this surface is 2 pi r square, just the half of this, and this new surface will also give me pi r square. So the surface area of a hemisphere is 3 pi r square, right? So these are the things that you need to take care of. In this chapter we will also talk about shells. Let us say I have got a hollow cylinder and this is a solid cylinder, okay. Right, I beg your pardon, this is a hollow cylinder where this inside is hollow, but this metallic portion is there, right. So if you need to talk about its volume, right, what will be its volume? The inside, let us say this radius is r and this external radius is capital R, okay. So if you look at the top surface, it is 2 concentric circles, with smaller circle with radius small r and the larger circle with capital R radius, right. Now if you need to talk about this area only, right, which I have shaded. So what will be this area? This will be pi capital R square minus small r square, right. What will be this area here? This curved surface area of the outer portion. It will be equal to 2 pi capital RH, right. Now if you need to talk about this area, the curved surface area from the inside, it will be 2 pi small RH, okay. Also, if you need to talk about the total surface area, then what will be the total surface area? Combinations of this area, area on the inside, area on the outside. So if I need to talk about total surface area, it will be equal to 2 pi RH, this is the area on the inside curved surface, right, plus area of the outside curved surface plus this area and this area. So it is twice of pi r square minus r square, right. So this was about right circular hollow cylinder. Okay. Now if you need to talk about the volume of the metal used in this cylinder, so what is the metal used? Metal is this, right. So what is the volume of this metal used? What was the volume of a cylinder? It was pi r square h, right. So if I subtract pi r square h minus pi small r square h, it will give me the volume of metal, right. I am not talking about the volume that can be contained in this cylinder. There is nothing that can be contained, right, because it is open from the top and bottom. So I am talking about the volume of the metal used, okay. So this is the volume of the metal used, pi h r square minus r square, right. If you close it in the bottom, now if you want to put something inside it and you want its volume, it will be just the volume of this inside cylinder, that will be pi small r square h, right. Okay. We can also talk about a spherical shell, right. Let us say this is sphere and inside it there is another sphere, right, which is hollow from inside. This is hollow and this is solid. So this will be a spherical shell. Now if I need to talk about this metal here, volume of this metal used, what will be the volume? 4 by 3 pi capital R cubed minus small r cubed. What is capital R? It is the outer radius and this radius is small r, right. So this will be the volume of metal used in a spherical shell. And if you need to talk about its outer area will be equal to the bigger sphere, right. Outer area is equal to area of the bigger sphere. So 4 pi capital R square. If you need to talk about area inside the spherical shell, it will be inside area 4 pi small r square, okay. So these questions are just based on your aptitude. You should be thorough with these formula and then you can apply these formulae in the questions, right. Let us say I give you a combination of solids. So I will break that combination into individual shapes, solid shapes, for which you know the formula, right, and then we will add those calculations, right. Let us say you have joined a cone, for example, let us say this is a cone and you mount a hemisphere on it, right. If you need to know about its surface area of this shape, right, I will calculate this surface area, which is the curved surface area of the cone, right, and I will calculate this surface. Let us say this is R and this is H, okay. So what will be the curved surface area of the cone? If this is, let us say, L slant height, it will be pi r L. It is the curved surface area of the cone and you have got this hemisphere mounted on it. So this will give me curved surface area 2 pi r square. So what is the total surface area of this shape? This shape will have a total surface area of 2 pi r square plus pi r L, right? So if you take pi r common, you can write it like this, 2r plus L, right? So we will talk about various combinations of solids in this chapter.